All right, our work today is going to come back into our Chapter 2, Unit 2, Linear Equations, Inequalities, and Systems. And we're going to start looking at our third form of a linear equation, which is in the form ax plus by equals c, which is also called standard form, where the x and the y are on the same side of the equation, and be able to graph that and maybe rewrite it in some different forms. But as always, we want to think about our equations within the context of a situation and be able to write an equation given that context. So the first problem says that Jada has $20 to spend on games and rides at a carnival. Games cost $1 each and rides cost $2 each. Which equation represents the relationship between the number of games x and the number of rides y that Jada could do if she spends all the money? All right, so we're talking about our two variables here, number of games, all right, and games cost $1 each. And then we're also talking about the number of rides, y, and we know that rides cost $2 each. And we also know that there is a total cost, or a total amount that she can spend, which is $20. So you'll notice that each one of these equations ends with that 20. Okay, but let's be thinking about which equation then also represents the other parts, where we're talking about the games that cost $1 each and the rides that cost $2 each. Okay, so $1 per game and $2 per ride. That means that we're really going to end up with this equation right here, because you're talking about $1. Remember that there is a number in front of that x that's a 1. If you don't see the number there, we know that it is a 1 because it is a 1x. And then you have $2 times the y value. So this equation right here would represent the situation that we are talking about. All right, so there's the 2 times the y, and we know y is the rides. All right, so let's just basically write in words what we were just talking about there. So if x is games and y is rides, then $1 per game and $2 per ride added together equals $20 total that Jada spent. So we know all of those had to add up to $20 if she was going to spend her entire amount. So the other two equations there could possibly represent some meaning in a situation. So let's think about what A would have represented up here. So let's think about A. So in A, we really have a 1 and a 1 in front of the x and the y. So if we think about that meaning, all right, we have $1 per game and $1 per ride added together equals $20 spent by Jada. Okay, so we still have that 20 in there. All right, if we look at the second equation, sorry, the phone is ringing here. If we look at the second equation over here, actually, no, in B, then we have $2 in front of the x. So 2 in front of the x. So $2 per game. And there's still that 1 in front of the y. So, and $1 per ride. Added together equals $20 spent. So both of those other equations could very well have represented this situation with some slight modifications in the amount that the games cost and the amount that the rides cost. But the one that represented the situation as described up in number 1 was that part C equation.